So we learned about use callback. Attached, you find a new mini example where I also want to dive into another hook that helps us with another optimization we could add. Here we have use callback to basically store a function to not recreate it. This is a function which I pass to the button through the onClick prop. The button internally uses useMemo, and because we store that function with use callback, the button will never re-render in this case, because its props never change, and React is aware of that. Now I'm also rendering a list here, and the interesting thing is that the list is sorted. It's sorted in an ascending way. Now, the data which I put into the list is not sorted, it's in random order, as you can tell here. So that means that, of course, obviously in the list we're doing some sorting. And indeed, here I'm sorting my list with this simple built-in sort method, to which I just pass a function that defines how the sorting should happen. You can look up the sort method documentation if you want to learn more about that. And that gives me my sorted list, which I then output. Now, the thing is, sometimes in your code, sometimes in your components, you might have logic like this, which could be a bit more performance intensive. Obviously, that's a short list, sorting will be quick, but for longer lists or simply for other tasks, you might have some code which takes quite some time. Eventually, this code of course needs to execute, but you certainly don't want to run this code every time the entire component is re-evaluated. Now, of course, we learned what we can do to avoid unnecessary re-evaluations. We can use React Memo here, right? With that, we can wrap the demo list. And with this shouldn't run unnecessarily. If I now console log demo list running here, we see that, of course, it runs initially. That means the list was sorted, but thereafter it shouldn't run again. Well, actually, I have this button. When I click it, I change the title here, and the title is part of my list here. Therefore, when I click the button, demo list runs again, and it needs to run again because one of its props changed, the title changed, it has a real different value there. So React Memo is not failing, it needs to rerun in this case. Now, as a side note, of course, currently it would always rerun when the parent component re-renders though, because at least this array here is constantly recreated in the parent component whenever the parent component runs. So even if the title would not change, if the parent component would rerun for some other reason, the demo list component would be re-executed because we always generate a new array. Like functions, arrays are objects, objects are reference values, and therefore two arrays, even if they have the exact same elements in the same order, are never the same, because they occupy two different places in memory. But here we don't even have that problem, but instead, as I just explained, because the title changes, we have a valid reason to rebuild demo list. So sometimes the component reruns is re-evaluated, and still you might not want to repeat every bit of work you did there in the past, especially if the work you would have to redo is more performance intensive. And sorting is one of the more performance-intensive tasks you can do in your components. So, is there a solution to that? Yes, there is. We have use callback to store function objects and only rebuild them when some input changed. We have something similar for all other kinds of data. And that is another hook which we can import, the useMemo hook. useMemo basically allows you to memoize. So basically that means to store any kind of data which you want to store, just like use callback does it for functions. And here we could memoize, and yes, that's memoize, not memorize. These are two different terms, but it's pretty much the same here in this context. So you can memoize the result of this sorting here, simply by calling useMemo here, and now useMemo as a first argument wants a function. That is, however, not a function that will be memorized. Instead, that function should return what you want to store. So in this case, it should return that sorted array. Now, just like useCallback, useMemo wants a second argument, which is an array of dependencies. Basically, to ensure that this stored value is updated whenever one of the values you're using in there changes. And in this case, indeed, whenever items changes, whenever we get new items, we want to resort them. So items are a dependency here. We could add props here because items are pulled out of props, but that means that the entire props object is our dependency, and therefore this would essentially always recalculate. So a more elegant way is something we used on useEffect and its dependencies earlier in the course. We can use destructuring to pull something out of props, in this case, to pull the items out of props. And then we can just add the items here as a dependency and use just items here for sorting. And now this will only rebuild this if items changed. Now let's see when that happens. For that I can add a console log here, items sorted. Let's see how often this runs. If I reload, we see it runs initially, of course, but it still also runs when I change the title. Now the idea was that it shouldn't run there. Why is it running again then? Well, because items indeed changed. That's what I mentioned earlier, a few minutes ago. The items here actually are always recreated when app reruns, because we always create a new array here. So even if it's technically a similar array with the same values in the same order, it's still technically a new array in memory, and that is treated as a brand new object, which isn't the same as the old array, even if it contains the same values. That's this reference value thing I mentioned a couple of times throughout this module already. So to ensure that we don't unnecessarily pass a new array here, we can of course also use memo here. We simply import useMemo, and then here we can wrap it, add this function which should return this array, and add our dependencies, which here is an empty array. We got an empty dependencies array here because here this of course never changes. It has no external dependencies. It's all hard-coded in here. So therefore now we also call useMemo here, and of course we can also pull that out of there and say list items is the result of calling useMemo, and then we pass list items here to items. And with that now, we should not unnecessarily sort the list again. Now we see items sorted initially, but if I click change list title, we don't see it again because of useMemo. Now, I will say you will use useMemo far less often than you use useCallback, because memorizing functions is much more useful, and you need that more often than memorizing data. You essentially want to memorize data if it would be performance intensive to recalculate something based on it. Otherwise, it might not really be worth it, because you always have to keep in mind that if you store data with useMemo, of course that occupies some memory, and of course this storing functionality also takes up some performance. So this is not something you want to use on every value you're using. If you got a scenario like this one here though, where you want to sort something, then it might be worth a look, because then using useMemo and avoiding unnecessary sorting steps in future component updates, that might be very well worth it. Now, throughout this course, of course, we'll see more examples, and therefore throughout this course alone, you will get a better feeling for when you want to use what. In this module, I just want to put all those things out there and explain them so that you understand them and so that you are aware of them. When you use them, always comes with experience, depends on your preferences, your exact use case, and there also isn't a clear right or wrong. It's just something you should be aware of so that you can look into optimizations like this if you find out that your application is slow or that you want to improve some parts of your application.